Welcome, everybody, to Weekly Quantum World Detangled, Season 5, Episode 2. I am joined by my friends and co-hosts Denise, Ruffner, and Atom Computing.
Hi, everyone. Coming to you from Southern California, early in the morning, but a beautiful day. And André and I managed to wear matching outfits. So welcome.
Great minds think alike. We have an even greater mind, and I always get excited when that great mind joins us from Europe. Tommaso, please introduce yourself.
Nice meeting you. I'm Tommaso Calarco. I am a theoretical physicist working on quantum optimal control and director of an institute for quantum control at Forschungszentrum Jülich, Germany's biggest research lab, and also working in several roles at the level of the European quantum flagship.
It's a pleasure to have you, Tommaso. You're a well-known figure in quantum, but let's see if we can learn a couple things about you that people might not yet know. Obviously, you're from Italy. You're currently working in Germany. You're very involved at the European level. You also travel a lot abroad. Can you give us in a minute or two your personal story? Where were you born? How did you grow up, the schools, and how did you get to the point that you're today?
Oh, well, yes. I was born in northern Italy, next to the mountains, which is something which I miss very much in this flatland, which is around Cologne. And I guess, how did I get to doing science? I guess it was playing with Lego blocks. And actually, so I just wanted to perpetuate that feeling. And so that's what I'm doing, playing with Lego blocks, with the different building blocks and parts of a bigger machine, which might be a quantum computer or other quantum technology device. So I did my studies in physics when quantum technology did not yet exist, because as one can see, I'm rather old. And then at the time, quantum was like foundations philosophy, something utterly useless. And so that's probably why I started doing this. And then it turned out to be useful, to my big surprise and excitement. But it was certainly not the motivation for doing that. It's the fascination. And also this is something which I think is still very much alive in all we do also in the field of quantum technologies.
I'm originally from Frankfurt, so always very excited when I see somebody with your pedigree working in Germany. How did you end up in Germany? Germany is very well known for its basic research and theoretical work. Is that the main reason?
Well, yes, among the main reasons. Actually, I moved up north, in my career. So my first postdoc was in Innsbruck, which is the birthplace of one technology in which Denise was working on in her previous job. And now with the first quantum unicorn, which is IonQ, the first ideas were born in the small city of Innsbruck. So it was very exciting for me to move there. And then I moved further up towards Ulm, where I got my first professorship after a couple of years at Harvard University. And then those were the years in which Germany was really moving towards a much stronger presence in quantum technologies altogether. And so this is one of the places to be to make things happen now. And so this is why we decided to stay here, actually.
You and I, we also sit on the Münchner Kreis think tank, which is a strong German think tank on new technologies. You're very involved at the European and international level as well. I many times tell people that Europe really doesn't have to be ashamed compared to the US when it comes to quantum technologies, for one, when you look at new technologies. What's kind of your view on Europe in quantum technologies, and how does it compare to maybe North America? Differences, collaboration, outlook?
Yes. So, well, there are some areas in which Europe is lagging behind. Most notably, I should say, very honestly, superconducting quantum computing. Clearly, the big successes which IBM and especially Google had, are yet not matched by our efforts. And I'm saying I'm honest because actually Jülich, where I am now, is the European Center for Superconducting Quantum Computing, and we are catching up, quite rapidly, but still we are not at that level. One should acknowledge that. On the other hand, and I can say that also with pride, because as I mentioned, I come from the atomic, molecular, and optical physics side of quantum technologies. Really, we can say that in such fields as ion computing and atom-based quantum simulation, we are also quite strong. And in this sense, we are really on the cutting edge. at a comparable level with the US. You know, in some cases maybe Europe is more advanced, in some cases is the US, but this is fine structure. So as a matter of fact, we are ahead both. And actually, we would wish from the scientific side a lot more cooperation. You know, my previous phone call this afternoon was with the European Commission discussing possible ways of, you know, cooperating more strongly with the US. Now there is a new body, which is the TTC, the Trade and Technology Council, in which, you know, such aspects of cooperation between Europe and US are being discussed at very high level. And of course, on one end, this is the wish of the scientists to have a stronger cooperation. I have coordinated in the past big European projects in which some prominent actors from the US were involved. But now that we are moving more into the competitive area, the Commission is sort of putting strong restrictions in this direction. And it would be great to be able to overcome those. We can, as scientists, not be very naive in terms of there is a concern in terms of IP. Like the European Commission says, we want to avoid that all the value is created outside of Europe. It's not about the US, but outside of Europe with ideas which are developed in Europe. Let's not forget that the World Wide Web was invented in Geneva, and then the money out of it was not made in Europe. And it's understandable that the Commission wants also to take part in the value creation. And the way in which we can do that is with some reasonable agreements about IP protection and regulation, which we should be developing in order to move forward. I had at Photonics West in San Francisco last week a discussion with our director of the European Quantum Industry Consortium, QUIC, together with the director of the US Quantum Economy Development Consortium, Celia Merzbacher, and with Thierry Botter, our director. We discussed together how we could possibly move forward. There is a strong interest both from the science and from the industry side, and we have to overcome some challenges, and I'm optimistic that this is possible to be done.
And private capital, entrepreneurs, ecosystems need to step up as well in Europe to then bring these technologies to market and keep the money in Europe, hopefully. But quantum is still a big, happy family. What do you do, Tommaso, when you're not thinking and working in quantum? How do you relax and maybe change your mind a little bit?
Oh, the way I relax, so I had another life with music. So I sing madrigals, so a cappella Renaissance music from the Renaissance, yeah. Well, this is one of the ways in which I completely brush everything off my mind. I mean, it really has to be something completely disconnected. I mean, I admire those people who can relax by reading a quantum physics book. I mean, this is not something that works for me. Yeah, it has to be really something different.
You absolutely need to feed your neurons with something very, very different. We'll get back to quantum. Denise has a ton of questions, I know, about your different projects at Jülich and the European level. Over to you, Denise.
Thanks, André. And it's a pleasure to talk to you. I think what I'm most excited about is the fact that I've heard that you are involved in a new startup. Could you tell us a little bit about it?
Yes, I'm very happy to tell that, because normally when I am speaking about European things, I of course try to refrain from that because I wouldn't want to sort of exploit any visibility in order to push that. But it's very close to my heart, because this is again Lego blocks, you know, putting together the pieces to make for instance, a quantum computer, and using control theory. So the institute which I'm leading in Jülich is the Institute of Quantum Control. This has been a big passion, which, by the way, for me started in the US during my year as a Fulbright Fellow at NIST. And this is where, so this was noise from my phone, so I will restart this. So 2 seconds. Well, I am very happy for an opportunity to talk about that. This is very close to my heart, even though normally I try sort of not to overdo or not to exploit any visibility at European level to push my business. So really, I wouldn't want to do that, but I'm very passionate about this because indeed, this is about Lego blocks. So, you know, putting together those pieces to create a quantum computer, a quantum machine, doing this via quantum control. So in fact, the institute which I'm leading in Jülich is the Institute of Quantum Control. And actually, this is a story which for me started now 20 years ago, which is a long time. You know, I was already a postdoc at the time at NIST with Bill Phillips and Carl Williams. And so in that opportunity, I came into contact with methods of optimal quantum control theory. And I suddenly was struck by the potential which these ideas had. You know, a couple other people were starting thinking in that direction in other fields. So I was pioneering the application of this to AMO systems, atomic, molecular, and optical systems. And we developed a library of algorithms and methods, which actually led us to something which also was a kind of a childhood dream. We made, this was 2 years ago, the fattest Schrödinger cat in human history, which resisted in that position only for a few months, because I think maybe for 1 year and something, because then Rainer Blatt made a bigger and fatter cat than ours. And I'm still very proud that we could compete with that. And the idea was that we implemented ideas of quantum control together with Misha Lukin to create this larger entangled state. And why am I saying that in context of the company? Because actually the funny story is that we have an algorithm which optimizes in real time, as a cloud service, if you wish, like the algorithm runs on our servers and the experiment runs elsewhere. And then I learned that Misha, at a conference when I met him some time after, he said, oh, I hope you don't mind, we have used your algorithm to produce another paper. And actually, I was extremely excited about this, and I wouldn't want to be an author of that paper, because that proved the point that really our methods work as a cloud service, in the sense that you can use them to make your experiment better without us knowing even. And this is really the kind of model that we want to pursue with our software, which we will offer as a software as a service, and also it can be installed in your lab. And the point is sort of low level, very low in the stack, just sitting above the hardware, trying to enable and steering all those quantum components and creating a time-dependent pulse, which can bring a high fidelity, which is, of course, the necessary element for running, for instance, quantum algorithms. So this is what we do with our tiny company, founded a couple of months ago, and now ramping up in the context of different German and European projects.
And, for company names, they all begin with a Q or something, but everything has the name quantum in it. I thought you guys came up with a very clever name. So maybe you want to tell us the name of the company.
Thank you. I'm also very proud of that. The name is Cruise, with a Q in the beginning, of course, because it has to be like that, but it is Cruise, like cruise control. So the idea is that we bring a cruise control to quantum, like you can push a button and your experiment will drive itself to the best possible fidelity, and you can sit back and relax. So that's the idea that we have.
Great idea. Great company name. I look forward to hearing more about it. Some other questions. I came up with some different questions. What do you think is the biggest challenge facing the adoption of quantum technology?
Well, I guess the biggest challenge is really the development of use cases. And this is not just for quantum computing, because this is something which we often speak about, use cases in quantum computing, software, and so on, in the, chemical industry or logistics and so on. But this is also a question which is very important for quantum communication, for instance, because secure quantum communications, there are some use cases which, could already be practical before we reach continental scale. For instance, smart meters for energy grids. Which require not so high data rates and not so long distances, but could be really something which enters in everyone's house. This is one of the strategies that we are having also at European level with the European Quantum Communication Infrastructure, EuroQCI, in which we are really looking forward to, creating a backbone infrastructure on which such services can be docked on. And somehow we need, like for the transistor, it was a decisive step using the transistor as a hearing aid. And without that step, maybe we wouldn't have chips now, because this is what enabled, the scaling, the production, mass production to a certain extent, and development of the technology. So really, I think that the challenge is really to get use cases, which does not mean we have the perfect quantum technologies and it's just a matter how we use it. It means we have very imperfect quantum technologies like NISQ computers, and we want to be sure that we already find something useful to be done with that. We cannot wait for the universal quantum computer. Otherwise, the quantum winter will come. I'm optimistic there will be not so strong quantum winter, because I'm confident we will find those use cases. And to do that, again, the tight interaction between industry and academia is essential. That's also the strategy we have in the other infrastructure we have at European level, the European Quantum Computing and Simulation Infrastructure, EuroQCS, in which we are providing access for the moment, to quantum processors coupled to supercomputing machines, and in the future, possibly also standalone as a cloud service, in order to enable industry to play with these devices, even though they are imperfect, but already to extract some value out of them.
When do you think we're going to start seeing impact on use cases in quantum computing? So I'm asking you to predict ahead.
Yes, so the current expectation is that if you sort of encompass under quantum computing also quantum simulation, the current expectation, at least in Europe, is that we are going to see real industrial impact and benefit, so outside of the academic domain, within the next 7 years, and probably not just at the end, but we will see first use cases emerging around the mid of this period. This is the current roadmap that we have with our European initiative, and also some of the projects which just have been submitted as of last week, because the first projects are really starting now, are envisioning. And so we are not only optimistic, but even without optimism, with certain doses of healthy realism, we can expect that this will happen.
That's great. That's quick timing, and I can't wait to see what the results are. So André, let me hand it back over to you for your rapid fire questions.
And before we get into the quiz, a short follow-up, Tommaso. I believe you said that we need these near-term applications, NISQ Advantage, and cruise control on quantum computers to avoid a quantum winter. Do you nonetheless believe in fault-tolerant quantum computers? Do you have this vision? Do you think that's something worthwhile pursuing?
I think it is worthwhile pursuing. And do I believe we will make it? The answer is I don't know, because it is a huge challenge, and there are pathways towards that, but this is seriously high risk. So I do not know of anybody who has a certainty of that in really practical terms. Theoretically, yes. And as we know, in theory and practice are the same, but in practice, they are different.
Absolutely. And some people are working on it. Maybe an Elon Musk, Tony Stark will surprise us one day with a fault-tolerant computer. Let's wrap our episode today with the famous muscle-bruised James Lipton weekly Quantum World Detangled questionnaire. 6 rapid-fire questions. Tommaso, your mission, if you accept, is to give rapid-fire answers. No right or wrong. Really just trying to dig into your heart and soul a little bit more. So if you're ready, let's get started.
I am.
Who is your favorite scientist?
Well, my first supervisor, Peter Zoller.
Your favorite entrepreneur?
I would say Elon Musk, because of similar reasons to what you said before, without reflecting.
What is the quality that you desire most in a scientist?
Ability to cooperate.
And in an entrepreneur?
Same.
What do you appreciate most about working in quantum tech?
The fun of making things which are science fiction reality.
And we've mostly talked about quantum computing today, but do you have a favorite current or future quantum tech application, maybe even outside computing?
Well, almost outside, it's quantum simulation. So my favorite would really be, quantum simulation for chemistry. That's something which I am very optimistic about. I'm not working on it, but it makes me very enthusiastic.
Do you have a quantum dream?
Yes, that really quantum tech will come into consumer products, during my lifetime.
Into consumer products, not enterprise.
No, consumer products. I have one. I can show it to you. Just one second. So it's here. I didn't anticipate the question, but so it was on my desk, not here at hand. So this is probably you know that it is a Samsung A Quantum. So it is a consumer product, but it is not really quantum tech altogether, because it contains a quantum random number generator, which, by the way, is European IP. And again, this brings back all this geopolitical discussion. But having something which is real quantum tech, in which you have the whole application dictated and substantiated by quantum tech in a consumer product such as this one, that would be my dream.
Very interesting. I'd love to do a different interview just talking about quantum consumer products. Fascinating suggestion. Do you have a quantum nightmare?
Oh, yes. That we have one day a wonderful fault-tolerant quantum computer and we do not know what to do with it.
And that is my last question. Imagine you wake up to a fault-tolerant quantum computer tomorrow in your living room. It's the only one in the world. You're not allowed to use it yourself. Who do you give it to?
Oh, I give it to probably, some government organization which can make it available for users from science and industry alike.
Very interesting. I wish we had more time to explore these many tidbits that you shared, Tommaso. We had a fellow Italian on the program last year, Davide Venturelli, who lives a few blocks away from me in Miami. He used to be a magician, and you love to sing, so maybe we can get some of that Italian artistry, beauty, creativity to quantum computing and quantum technologies, and certainly look forward to hearing more from you. This concludes Weekly Quantum World Detangled, Season 5, Episode 2. You are now detangled.